Yeah. Thanks for setting this up. And to our host tonight, I really appreciate the opportunity to be here. I've actually touched 7 states in the last 3 days.
Sweet.
So it's, yeah, I landed about an hour before I arrived. So that's the way it goes sometimes. All right, well, great to see such a great turnout. I want to just quick show of hands. How many here have ever opened up the Talent Studio and written a job? Okay. So those of you that didn't raise your hands, you're here tonight to learn about how to write jobs in Talend. That's what's going to partly happen. But what brought you to the event tonight?
For me, our group is currently using data stage, and the direction is to go with Talend. So our development team is going to use that Talend. So
Great.
I will be working with them. So for me, it will help me to understand the overall concepts and how things work, so that we can propose better solutions on how
Great.
to use.
So you're going to go back and you're going to have all the information. You can tell them what to do and how to do it. That's wonderful. Okay, so here's our agenda for tonight. It's about 90 minutes, but we'll see how it goes. We're starting a little bit late, but not too bad. I want to actually get a tour, Kurt, afterwards. This place is phenomenal. So let me just explain why we're doing this. I joined Talend a few years ago, and I had actually been a Talend developer in the field, and I asked my boss, where's all the content around best practices? And he said, well, there isn't any. Start writing them. So I said, oh, okay. And I wrote a blog. It wasn't my first blog for the company, but it was pretty close to the first one, and it was around this concept of job design patterns and best practices. And it was a hit, big success. So it's turned out to be actually a 4-part series. Now, have any of you read any of my blogs? No, you guys have got to get reading here now. In fact, my team is producing, let's see, there's 5 of us here in North America. We're doing a blog a quarter. So the content is just really fantastic. When I started, most of the blogs were very sales and marketing oriented. Not that that's bad. There's sales and marketing over there in the doorway. But there wasn't a lot of technical blogs. And that's really what my boss, Urshad, was challenging me for. So, and you can go and read these 4-part blogs. It's going to be pretty much the same content. We're going to cover tonight parts 1 and 2. But you can go read parts 3 and 4 and lots of good information in these blogs. There's several series out there. I've got a series on data modeling and a series on, in fact, I should bring this up because this is my latest blog, Successful Methodologies with Talend Part 2. So it really ties in with the content we're going to focus on tonight, which is really the best practices. But you saw my title slide is Job Design Patterns and Best Practices. So it's starting to finally grow, and I finally have in this blog some of my first actual job design patterns to share. Okay, there's 4 of them in here. There's lift and shift, there's migration, there's command line, and these are just different styles and ways of building jobs in Talend, and they have completely different purpose and use cases behind them. This one is a dump load, so it's actually 2 patterns. This is how you move data in and out of a data lake, perhaps. So read this blog. You'll find it very interesting, and it ties in with the material we're going to talk about tonight. So this just got published like less than a week ago, so it's really brand new. Okay, we'll touch on SDLC a little bit because that is imperative that we have a software development lifecycle focus. And then we're going to have at the end a little bit of some of the secrets, the tips and tricks that I've come up with. A little bit more about myself. I'm the regional manager of the Customer Success Architecture team. Now when I joined in January of 2015, there were 2 of us. My boss brought me in and we started building this CSA team. We really didn't know what it was going to do or how it was going to work. We fit in that gap that we've identified between technical support and professional services. Right? Support you get through your licensed subscription, and professional services you engage and you pay for consulting time to come on site. But there was this gap. So the CSA is designed to fill that gap. And we focus on, guess what? Architecture and best practices. So it's a good thing, and it's worked out quite well. There's 5 of us on my team here in the US today. There's 14 of us globally, and we're expecting to grow to about 22 by the end of the year. So the CSA team has been a great success, and I'm glad to be part of that. Now, I actually started working with Talend back in 2009. So I've found it tripping along. I got a job, and there was Talend. I'll tell you a story of how that happened if you're interested. It's strange, but I got involved in Talend in 2009, and I was able to leave Informatica and SSIS behind, which were my 2 main tools that I worked with up till that point. I even preferred to hand code over Informatica, so that's just a personal antidote. In any case, I've been a database architect, software engineer for a long time, and now landed at Talend. I really have great experience with this company to try and move the ball forward. Oh, hang on, I thought I hid those. Those are 2 of my team members that also do this presentation. Okay, I really want to encourage an open dialogue. Okay, I don't want me just talking to you guys. Ask me questions, interrupt me. I want to ask you some questions. So let's make it a discussion. I don't want to just be a lecturer up here, okay? So I'm counting on you guys. I'm going to call on you as well. All right, so I always like to start out by asking a question. And we're all Talend here, right? So what's the best way to write a job in Talend? Well, it needs to be easy to read, easy to write, and easy to maintain. Simple, right? Common sense. However, as most of us know, we can only get 2 of those at the cost of the 3rd. It's just fact of life, right? You can get 2 out of the 3, pretty typically. So I ask another question. Is this job I'm writing going to change over time? Well, yeah, probably. That's very likely. So I want to prioritize those things. I want to make sure that my job is easy to maintain, which means it has to be readable. So those are my 2 priorities. And yes, it's going to be a little bit more of a challenge to write that code. It's a fair trade-off. Now, what if that is a one-time job? One time only, you know it, guarantee it. It's a one-off, get it done quick, fine. Flip it. Make it easy to write, just knock it out. I really wonder if that's the case. Any job we write, there's going to be some reuse for it, right? So those don't happen too often. The real challenge is when you have a team, all trying to work on the same project, even work on the same jobs at the same time. So I think you really have to put the edge on the priority for making it easy to read. Heck, you got to make it readable so that when you come back in 6 months and look at your job, you know what the hell you wrote. Okay? So this is common sense stuff, I realize, and some of these first few slides, I'm hoping that even if you know it already, that's great. This should confirm that you've got the right track in place. If it's new to you, just as great. Ask questions if you need to. The reason why these are important is because in Talend, we paint our code. I started out, we all hand coded. We punched cards back in the early days, right? But we were hand coding in an editor and writing line by line by line. Well, Talend is a canvas with a palette of components that we drag and drop and we link together, and we're painting our code, yet under the hood, it's a Java code generator. And how we paint our code, yes, affects how the Java code is generated. And if you splash your code up on the screen, it's not going to work so well. Okay? All the basic functionality still has to happen. You've got to have error handling, memory management, performance. All of these are very important things that we're trying to achieve. And one of the first clues I can give you with Talend is to avoid monolithic jobs. Those big jobs that try and do everything. That is going to generate such a bunch of Java, if you even looked at it and tried to understand it, you would ask yourself why. Why am I doing this?
They wouldn't work, right? So 64 kilobytes plus, they won't generate a single class, so it will just fail.
It can. You can oversubscribe and get all kinds of problems generating the Java.
How do you do that? I never tried. I always had the problem, so I would use run jobs and stuff if I had to, but I don't know how to do that.
Well, try creating a job that handles like 1,000 columns in a schema.
No, 1,000 columns are fine. My problems are, so how do you oversubscribe? You said like, go ahead of 64 kilobyte for a single Java class. So like your generated code is too big.
It's too big.
Yeah.
You've got to write an awful lot of components and links in there to get there, but you can achieve that. We get calls and support with that from time to time. And the trick is just to avoid doing that. We really want to create atomic units of work. The Talend Jobs should be very succinct, and they do a certain purpose, and then you orchestrate them.
There's something that you can check too is that when you check your project settings, there's all these logs and stuff that will also, your job will also generate more code for it. If you're finding that you don't need a certain kind of logs and stuff, you just uncheck those and they'll limit the job code as well.
Yes.
Yeah, I got that. I was just like, I wanted to get the word, you said you can oversubscribe, like is there a way I can go beyond if I know I'm making the choice? It's my choice.
Break it into smaller pieces.
No, I know, I'm just asking.
That's it. That's it. That's the answer. You break it into, there's nothing else. You break it into smaller pieces.
Why I'm coming because it's not Talend's like
It's Java.
It's a Java limitation.
Java problem.
Yes.
I was just asking that from Java point of view, is there a place where I can change some JVM parameters and maybe it works?
Not that I'm aware of.
Okay, so
Not that I'm aware of.
so there's only way, yeah,
You mean you know fine? You say you're not aware of it.
I'm not aware of them.
okay. No,
That doesn't mean they don't exist,
Yeah, I
but
would say they don't
there is a limitation, and it's a pretty big one, but still, I don't recommend building those kinds of jobs in the first place. So avoid that. Okay.
You kind of touched on it, but you're going to bring the system to its knees, and everyone's going to hate you.
Well, yeah, if your job is that bulky,
Right.
if you're not taking into consideration some of the best practices we're going to talk about tonight,
Yeah, but that's,
memory management is a key one.
I mean,
Right.
operations are going to hate your guts.
Yeah. Okay, that's from a personal standpoint, right? Just try and maintain that code. That's something else altogether. So as a Talend developer, I also think it's important to understand the ecosystem and all the moving parts, because several of them are optional. Okay? Now we have this Talend Studio, that's one of our clients, and we have web browsers like the TAC and the AMC, and there's a few others. We have servers, which are the server side. Now, if you're how many of you are just using Open Studio, the free download version of Talend?
That's what I'm using now, but I did work before where I had to use it twice.
Okay, so you can download the free version and build functional jobs. There's some limits, and of course, you don't have any of the server technology, none of the cooperative shared development integration, all those other bells and whistles. And also, you get the execution servers. Okay, the execution servers are the agents that run the jar file that's compiled and built from your job. Okay, your job, you paint your code, it generates Java code, which gets compiled into a jar file, and your execution server executes it. Now we have two kinds. One's called a job server, one's called an execution, a runtime, excuse me. They're exactly the same, except for it's a licensing issue. The job server, you can deploy as many as you want with your subscription. The runtime is used for some of our advanced ESB and streaming technologies, MDM, for example, that require a license. Okay? Otherwise, it's the exact same thing. It's an agent that runs your jar file. It's that simple. Then we have all the databases to support the metadata underneath the product. The main one you need, basic installation, is the Studio, the TAC, and the admin database. You can put that on pretty much any database, but MySQL, Microsoft, Oracle are the primary ones. Postgres is fine. It comes with a default called H2. Don't use that. Please. I wish we could get rid of it. It's legacy, it's sitting there. It even says not recommended. You'd be surprised how many customers actually still use it. I wish they wouldn't, especially not in production. So use a real database and build your TAC metadata on that database. And then we also have some repositories. We support source code repositories, SVN and Git, and we support the artifact repository, Nexus. Okay, as of version 6, we support CI/CD with the Maven architecture. We'll touch on that a little bit in the next couple of slides. But repositories and databases, we kind of jumble those terms often. So when I use one term, I might mean the other. There's even this project repository, which is really a combination of the source code control system and the metadata in the TAC database, defined as a grouping within your project. But understanding this stuff, even if you don't have to use it all, is the first step to taking things seriously. Because we're doing serious stuff here, right? We're helping our employer run their company by building functional, successful, optionalized, operationalized, productionalized code, okay? That's what we want to do. And you can see here with Talend, there's a lot of flows of how things kind of integrate together. Okay, now all of this is in the documentation. You can read up on all this stuff, but I wanted to just highlight it. As of version 6, which has been out for a couple years now, and we just released version 7 a couple weeks ago, we embraced the Maven architecture. And we changed the way you actually publish and promote jobs from dev to test to production and so forth. And allow you to automate that process with tools like Jenkins and Bamboo. And now you only have to maintain your source code in development. Isn't that nice? That's the way it's supposed to be, right? All of our development environments in C# or Java would do it this way, so why not Talend? Well, we do it this way now. We didn't originally, and it took us a while to get there, but this has been maturing for the past 2 years. Continuous integration, continuous deployment. There's an article, document you should read. You go to help.talend.com and just type in SDLC, and you will find the Software Development Lifecycle Best Practices Guide. Please read it. It explains all of this. Now, I could spend another hour talking about just this. We're not going to do that tonight. We have some sessions that you can watch that are pre-recorded on this topic, and you can go read that article. Probably take you 20, 30 minutes. So I recommend it highly. Okay, now as developers, I want to focus more on the development aspect of SDLC. And I've got a list of what I call foundational precepts that are coming up on the screen here. I want you all to read these. Just take a look at them. And here's my first question to you. What, to you, is the most important precept on that list?
The one you didn't put down,
Which is?
the one we forgot to ask you.
Which one is that?
How it really is done?
How is it done?
Yeah, because sometimes when you program and you say you want it that way, me as the person that puts it in the ground and holds it there, we're going to argue. Because that's not the truth.
Okay. So which precept that's on the list would you choose as your most important?
Functionality, it has to work.
Functionality?
Long range functionality, like a
Yeah.
Consistency,
Consistency?
efficiency, efficiency.
Efficiency? All right. Those are all good.
But I mean, you can't have one without the other.
You're looking at the top, right?
You can't have one without the other.
You're looking at the top of the shell.
Just in general. I mean, I don't care whether you're building a Talend job or writing Python. This list is damn near impossible to prioritize because you need to do them all. They all have to be in our head and the back of our mind all the time. I've heard things like functionality first, then optimize for performance. That makes sense, right? But all of these things, and I tried to prioritize them. I couldn't do it. Now, I will tell you later which is my favorite. I like saying this one, compartmentalization. I'm getting good at saying that one. I tripped over it a few times in the past. But all of these precepts make sense. And really, the trick is to bring them all into your thinking in your everyday coding efforts. Another thing that really irks me is, we got to have coding standards. I don't like standards. Standards imply things are rigid. They won't change. And how can standards account for things that change? How can I, if I have a standard, account for a new business rule tomorrow that I didn't know about? You can't do it. So I prefer guidelines. Now maybe I'm splitting hairs, and okay, I may even use those words interchangeable, but for standards, you need standards for certain things, like manufacturing a car or an airplane, right? You got to have standards for those things, but you have a fixed object. Software is different. Software needs to be pliable. Okay, it needs to bend and not break. And if you have standards, then you can't account for everything that might happen tomorrow. So what I do is I prefer to get together as a team and discuss what are our guidelines going to be. Agree to those and adopt them. It's really about discipline, okay? Making sure that everybody has skin in the game. Let's all do it this way, okay? That way you're going to evolve, and you can even do this in an agile way. You can evolve these guidelines over time and improve on them, okay? In fact, this is where I get to hand out my guideline, which is just pass them back if you would. An outline for what might be useful to you to create a developer guideline document. And I recommend that you actually create the document as a team. It's a living, breathing thing that you can put into your agile sprints, and every sprint you evolve it and maintain it and improve on it, and it gets better and better. A year from now, you'll look back and you'll say, we couldn't live without this. It becomes your Bible for the new hires, right? Another useful document I really call out is the data dictionary. Talend is a data integration software product. It's a tool that allows you to do integration of data. So make sure you understand the structures of your data. Have a data dictionary to do that.
So I have two questions.
Okay?
Can you go back to the Talend, the slide, Talend SDLC best practices guide? I think it's 2 or 3 slides back. So there's really, oops,
This one?
no, the one with the readability, writability, all your abilities. Forward.
The precepts?
One more, yep, there's a one. Yeah.
Okay.
So where would you put customer requirements in there?
I don't think customer requirements are necessarily a foundational precept. They're a functional precept. Okay? I've got nothing in there that is going towards that aspect of it. Okay? That's a good call out, but that's not what I'm aiming at here. This is all about writing jobs.
Right.
Now,
the
I
first
can't-
step- no offense.
No,
The first step in SDLC, many years ago, you and I probably have done.
Waterfall.
these a lot.
gather
So
requirements.
the first, which is the
I'm not-
customer requirements. So you get
Yes.
the requirements, and then you come up with your business design. And then you go back to the customer and you say, are you sure?
And I understand where your question is coming from, so let's put it into context. I'm not doing a talk about the software development lifecycle. I'm carving out one piece of it. Okay, so you're absolutely right. Requirements gathering is a key ingredient to waterfall, agile, or whatever you're doing. Okay, I'm focused in from a developer perspective. Let's assume in my talk here tonight, you've got those requirements. Okay, and some of the other DevOps, that's not what we're talking about tonight.
But still, I mean, it all starts because someone's willing to sign a check.
Absolutely,
And then
absolutely.
The other thing is about flexibility. So someone changes their mind midstream.
Well, I have pliability.
Well, pliability is to make sure that the code can reach the outer edges of wherever that is and not break,
Yeah,
as opposed to.
flexibility is a good one. That I.
Business model changes. So if you're dealing with commercial enterprises, they have to be agile, not in the sense of agile development.
That's true.
But to be able to change their priorities, or they could become a buddy good company.
I completely agree. You're absolutely right. So that could easily be a precept. I'm not saying this is a complete list. Because I would add that one to this list.
Because all of us have gone down a path, and then someone says, oh, I changed my mind.
Yeah, it happens all the time. Happens all the time. Which is why I prefer guidelines over standards. Okay, develop those guidelines to be pliable, to be flexible, to adapt to change. I talk about adapt and adopt all the time, right? You're going to have to change. Develop your guidelines in an agile way, and you'll be able to accommodate change of mind. Happens all the time.
I like the first slide which said about how writability and then maintainability.
Yes.
So you can choose of what your job is doing to make the judgment. So I like that one too, that reaches out. So I have all those kind of stuff, utilities, regular jobs, operationalized jobs. So I can see how I did it so that a couple of them have been running every 15 seconds for 2 years and they work fine. Others that are like more, like a lot of team members, like multiple, like 20 people in the team are working on it. So.
Well, and if you've got 20 people or 10 people or even 5, you want everybody to do things about the same way. But you don't want it so rigid that they can't explore and experiment and find new ways to solve problems. Okay, that's got to be baked into the overall best practice. And one more thing, it's really about habits and investing in yourself and your team to create good habits. And in Talend, what I recommend is start out easy. Do something that everybody on the team is willing to do and it's easy to do, which is label your component. It takes all of but 2 seconds to label a component and come up with a nice format. And I'll show you, I'll highlight my preference for me that I share with my teams. But do that. Once everybody has that as a habit, it's automatic without thinking, label my component, right? Done. Raise the bar. Now let's all use a proper naming convention. Raise the bar. Now let's use a directory structure that we can all agree is a nice way of formatting where our projects are, where our jobs go, where our data files go, all those kinds of things. And incrementally raise the bar over time. Adopt logging and messaging capabilities. In the end, your discipline improves and you achieve that easier to read, easier to write, and easier to maintain mentality. You might even get to all 3, at least to where the one you sacrifice the most isn't painful. Okay? So let's dive in a little bit. What are job design patterns? Well, I showed you one, okay, on my blog. So is it a template? Is it a skeleton? Well, yeah, it kind of is, but I think it's more than that. It's bound around the use case. Okay, and what we really want to do is we want to design our Talend jobs to be reusable. So you want to identify those common elements that you can reuse across your project. So let's say you have to do 20 things, but it's almost exactly the same. Just one thing is different 20 times. Do you write 20 jobs? No, you write one job, you make it a little bit smarter, you pass in an argument, and you put in a condition statement, and you do all 20 things in one job. Compact your code, make it intelligent, make it reusable. That's what is the strength of Talend. It's object-oriented, so realize that you're building object-oriented code, Java, under the hood, and design your jobs in that way. And yeah, base it on a skeleton, like the ones that I'm highlighting in my latest blog, lift and shift, migration. There's some for microservices, there's some for big data, there's some for data lakes. Lots of use cases will have a different pattern, okay? I have another one I call chunking. Look for that in the next blog.
So in streaming large data, are you using something Hadoop that's inside, or is it outside, and you're just sitting there waiting for the data from the different databases to come to you?
Well, in a streaming architecture, you probably have a Hadoop ecosystem, and you'll use something like Kafka and Spark to manage the stream. You can do that with Talend.
Inside native to Talend?
Yeah. Well, it's not native to Talend. It's native to Java and Spark. Okay, Talend is a tool, right? It's not native anything. It implements native technologies like big data, Hadoop, like Spark, like MapReduce. All these things are generating native code when you create your Talend job. Okay?
I have a question. I haven't used your studio yet, but what language you mentioned coding, right? What language you use?
Well, it's a canvas, right? It's a drop components and link them together, but it generates Java. It's a code generator.
Can you customize any?
There are ways to enhance the Java being generated. So yes.
But then what language do you use?
Java.
It's still Java.
Java. It's not BASIC, it's not C#, it's not Python, it's not any of those. it's Java.
So mainly operation is a drag and drop in the studio. Then if you want to customize using the Java language.
We have multiple ways to do that. Okay, there's a T-Java component. You can drop that into your flow and add whatever Java you want. We have code routines where you can create your own Java class methods. There's lots of ways to do that.
Is that your job is running on pipeline?
Is the job running on a pipeline?
Pipeline design, right, or not? Like for example, you have data ingested in, right? Then you have output, whatever,
Yeah.
or database. Then you should draw is that a pipeline process kind of?
Well, we'll look at that. Let's get into some of that. And you haven't used Talend before, right?
Because it shows you the right one.
Yeah. Okay. I don't want to. I'm happy for the interaction. That's what I look for. So great question. But you haven't coded in Talend before, right? You haven't done it yet. Okay. So you're going to see some of that, and maybe some of that will. Yeah, some of that will be clear to you in some of these best practices that we're going to do. Okay. So let's dive into some best practices. Ready? Okay. Let's look at best practice number 1. That almost goes to your question in a way. What is the way to lay out the canvas? To start with this, it's so basic, so fundamental that when I first started, I looked for examples. That's a normal thing to do. I found a lot of examples, and I found what I call the zigzag pattern. Okay? Start from the left, go to the right, come on down, go back to the right, forming a zigzag. Guess what? This is hard to maintain. Very hard to maintain. So it blows that rule out. If you're doing a quick one-off, maybe you do this. But functionally, I found this very frustrating. So I stopped doing that. Then I found what I call the snake, kind of going any which way comes Sunday, where your components are linked up all over the place. This is hard to read, let alone hard to maintain. I see this code all the time, and it's all scrunched up. You have a canvas with scroll bars. Use the space, lay it out. And what I found was the best way to do this is top to bottom, left to right. So your process flow is essentially top to bottom, and your data flow is essentially left to right. Now remember, this is a guideline. You can bend the rules a little bit. You'll even see I go right to left sometimes. I even invert it and do my data flow top to bottom and my process flow left to right. Depends on your use case and what you agree to do as a team. But I really think this very nice, simple, straightforward layout works. And you can just cut that on subjob OK, move the block down, insert code, really easy to maintain. And guess what? With those labels, really easy to read. And guess what? It's not hard to write it this way. It doesn't take any extra effort.
Nothing to do with this, but just wondering, the data in this slide will be in the block?
Yes. Yeah, I talk about all of this. Every one of these best practices are in the blogs. Okay? Does that make sense?
That's just the logical way to do it.
It's a logical way to do it, but it took me 3 or 4 years to get to this point. So anyway, try not to just throw your code up on the screen. I mean, come on. Take an effort to format it in a nice way.
Disadvantage is like, as a developer, I like to see my code in a screen where I don't want to scroll the code.
I understand that, and I have to resist that. But you know what? We have a zoom. You can zoom the code.
You can have a 20, like,
And if you can get a bigger screen. I mean, come on, don't squish it all in there. It has to be readable, right? I always have at least, how there's a grid, right? I have usually about 4 blocks to separate every component. Sometimes when I really want to squish it in, I'll go to 3. But that's just my personal style, right? And if you want to adopt that as a developer guideline in your team, fine, do that. But at least follow the top to bottom, left to right.
I don't use it, but you can actually go just straight top to bottom and left to right, but then like minimize. So you create a really compact job.
Yep.
And only expand the code when you want to edit it, and then knock it back to a little component.
Well, that's a joblet that does that.
Is that job?
Yeah. Because a normal job wouldn't do that.
It does. A sub job could be A sub job itself.
A joblet will do that.
A sub job wouldn't do it. You're right.
Sub job won't do it. We'll see that.
A sub job would do it. A sub job could be like when you say.
We'll see. We'll see. I'll show you what I'm talking about, and then we can see if we're talking about the same thing. Okay. So number 2, and this goes to that first point I made. Don't create these monolithic jobs. So how do you deal with compartmentalization? Right? You have an orchestration capability with Talend by being able to create a job that can call another job, a parent-child hierarchy. Okay? So this is how you avoid those monolithic jobs. And here's just a really basic, simple example. Okay? Where I'm using a T-run job right here to call another job that I've written separately. Now I want to call out the fact that when you use this component, and here you can see the T-run job component settings, there's 3 checkboxes. It's very important to understand what they do. The first one, use an independent process to run subjob. Okay, I wish that said to run child job, because there's confusion between what's a subjob, what's a child job. We're talking about a child job, which is physically a separate job. Within a job, you see those blue boundary areas that wrap around one or more components? That's a subjob. Okay, so we're talking about child jobs that you can invoke or call from your parent job using the T-run job component. This is Java. So when we turn on the use independent process to run that child job, what we're doing is spinning up a new JVM for that child job, which means it has its own core and its own heap stack memory allocation. This is a very important and significant checkbox. Let's say you are orchestrating a 3-level hierarchy of jobs. The purpose is to move 20 million records. And the 3rd job in the chain is what actually does the heavy lifting. So you have the first 2 jobs, maybe accept some parameters, set up some conditions. It calls the 2nd job, it does some manipulation, gets it ready to actually call the final job that does the heavy lifting. Why not have the first 2 jobs run in one JVM with a lot less memory and allocate more memory and use an independent process to run the 3rd child job because it's doing all the heavy lifting?
So if you don't check that, the memory used by a child job would be based on the parent setting.
Yes. So the parent job, when it first fires up, has a JVM. A child job is going to run in that same JVM unless you check that box. Okay? Doesn't matter. That child job has, and I'll show you where you can set the memory for a job. There's only one place you can do that in the job, on the Run tab.
That's what I was talking, but
Yep.
it doesn't apply to.
No. No.
Good to know.
Yeah, these are little tricks, right? The second one, die on child error. And this behaves a little differently depending on how you've set up your orchestration, right? Die on child error is one of the few places you can actually control whether or not you bail out of your code right there. Okay? If you turn that on and it's running in the same JVM, it will bail out of the JVM. If it's running in its own JVM, it won't. It will return from that child job with an error, and we're going to talk about error handling. So we'll be able to see how to manage that. Okay? And the third one, kind of completely unrelated, is transmit whole context. So for those who have programmed in Talend, you know that we can create context variables. Okay? And Java passes by value, not by reference. So by default, transmit whole context means all of your context variables are going to be copied in memory and given to the child job. Now that is another significant thing to think about. If it's all in one JVM, that means you have 2 copies of those variables in memory. That may be fine if you've only got a few of them. But what if you have 100 of them and your child job only needs 3? Take the time to uncheck that box and specify the 3 variables you want to copy down into your child job. And of course, run it in a separate JVM if that makes sense.
Sorry, Dale, I just want to ask a question. So if we run it at the parent level, can we specify separate memory allocation parameters for the 2 pieces?
If you check the independent subjob process on, then the setting that I'll show you in best practice number 14 will apply that very thinking. If you don't turn that on, then it's going to use the memory setting of the parent. which you set in the Run tab. Okay? The Run tab.
I'll ask you a similar question when you show that. Now, before you go there, the transmit the whole context is very easy as a developer. If I have 20 sub-jobs I'm running in a master job,
Yeah.
each job is using one variable.
Yeah.
If I'm doing a code review, whatever code you've written, I'm gonna dive in by verifying variable in each job. So I'll just go ahead and do all transmit whole context. That's easy, right?
It's easy. It's also lazy.
Yeah, and then
Okay.
when you're doing implicit context loads, they won't work anyway. So you want to manage that on your own.
You do, and you should manage that.
I would not recommend transmit whole context. I always go for individuals and then go for implicit load. That is what. Because the
And that's one way around it.
Yeah.
We have everything transmit whole context.
No, okay.
By default, that's what most people do because it's just turned on and we don't think about it. I'm asking you to think about it. Okay? Make the choice to copy. Remember, it's a copy. It's not the same instance of the variable. So you're not being a memory management good citizen.
How much memory is going to take it?
Well, it depends on how many variables and the type of variables you've created, obviously. So
200 string variables. Do we have
if you've got 200 string variables, that's really bad practice.
how much memory is going to take?
Do the math. I'm not going to,
Kilobytes, but still like.
yeah, character, 2 bytes per character, figure it out, right?
I don't agree, like, giving for each one variable, because as a development, I see a lot of drawback. After 6 months, you come and seeing your job. Again, if you modified 4 or 5 jobs and if you add a new variable in your sub-job, you need to come to your master job to add those variables again.
Not necessarily.
If you
Not
transfer-
necessarily. Your child job might use a variable that your parent child doesn't care about. So you can have a variable in your child job that doesn't exist in your parent. You don't have to pass it.
Correct, but that way, if you check it, it's no harm, right? Like,
There is harm, and I'll explain what harm it is. Jobs run on a job server, and they use memory. They set up JVMs and allocate heap and stack, and you have multiple jobs being run on that job server by other developers, and you're not managing the memory properly if you don't uncheck that box. Okay? So if you've got a big chunk of memory and you only need this much, that is just bad citizenship on that job server, and you're going to limit the amount of jobs that you can run, which decreases scalability.
do we have any documentation saying these variables cause this much memory, something like that?
It's just pure, simple allocation of memory by bytes. You want to do the math on how big your string is and how many bytes you're taking up. You can calculate how much memory. There's a place where you can actually figure out how much memory your job uses. I'll point that out when we get there on slide on best practice 14.
It doesn't matter more, and you have just a whole bunch of connections.
Yeah.
Every bit counts.
Yeah, if you've only ever going to have 5 or 10, I've been lazy like that too. I admit it. But for production-ready code, you should take the time to figure out exactly which variables you need. And you're making a copy. And if you're nesting an orchestration of multiple jobs and you're copying them again and again and again and again, now suddenly you're causing impact to the memory footprint of that job running on the job server. And other jobs need to share that resource. So you're not being a good citizen by just default always copy everything. Okay?
I never face problem, that's why I'm not being a good student.
Okay. I know it's easy to ignore it, right? But that's what I said. It's easy to read, easy to write, easy to maintain. So this is one of those, it's harder to write, but it's better.
And it's hard to hear that something you consider best practice that you're doing is not really best practice.
That's right. And that's a good call out as well, because for your team, create whatever best practices you want, right? Whatever works for you. Okay, so if you think it's a best practice to keep that turned on and everybody agrees, fine, do it. Be consistent about it. That was your call out, right? Consistency. So do it that way. All right. This is great. We're only on number 3. We're going to do 16 tonight, whether you guys like it or not. Okay, let's talk about joblets and run jobs. Okay, both promote reusable code, which is a great feature in Talend. The difference is fairly simple. T-run job calls an external jar file where joblets are included in your current jar file. Okay? So I have a sample here. It's the same one, but now we're highlighting a joblet. down here in the bottom. And notice this has the plus and the minus. So yeah, you click that minus, it will collapse. That's what you're talking about. I didn't want to confuse people. So this blue border around a component is what's referred to as a subjob. And if you have multiple components together that are wrapped around by the same blue border, that is in its entirety a subjob. We'll see some examples of that. And you can click that minus sign up in the upper left-hand corner and it will collapse it. That's what, and what was your name again?
Ewing.
Ewing was talking about that. Okay, that's exactly what he was talking about. Now, this guy down here has that same minus sign, but it also has this plus sign, which is what I was talking about. Okay, that's a joblet. That is created as a separate code base. It's defined as a joblet, which means you can't call it, but you can include it in your code. And you can click that plus sign and it will expand that joblet code so you can, in read-only mode, so you can actually see it. But if it's connected to multiple other components as part of a subjob, you've got two levels of expanding and collapsing that you can do there. So there's really no reason to not spread your code out on the canvas because of these features. Plus the zoom, right, in and out. So that's essentially the difference between these two things. This particular joblet is special. We're going to look at that. It's called log processor. By the time we get to number 5, we'll see why.
Is it standard common tablet?
No. No, there's no standards here, only guidelines. But no, it's not a feature that Talend ships out of the box. It's something I'm going to recommend to you guys. Okay, so all I'm calling out here is that use joblets, use child jobs efficiently to orchestrate your reusable code. This is how you do it. In order to make it work properly, you need to understand entry and exit points. And I will admit we haven't done a great job in our documentation and our training classes to explain this. Now in this case, let me expand this guy. We've got a couple of interesting things going on. The first is we have a pre-job and a post-job component. These are relatively new, but for anybody who hasn't been working in Talend for years, they've been there for a while now. And they do exactly what they imply. Right? You connect your components to the pre-job and they run first. Notice there's no connection of any of those components to the body of the code, which is the call to the child job in this case. And then finally, it's going to execute the post-job. So what are some good things to do in a pre-job and a post-job? Open and close database connections. In my case, I'm checking to see if a file exists. And if it doesn't exist, I throw an exception, which is the tDie component and the twarn component. These are your way of throwing exceptions. Okay, we're going to examine that a little further. So those two components, tDie and twarn, are very interesting for operational logging. The pre-job and post-job are just better ways of organizing your code. Now you'll notice I'm actually bending my own rule. I'm going from left to right on my process flow for my pre-job and my post-job. This is because it makes it a little bit more readable, I think. But really, I'm doing a top-to-bottom flow for the job. And if I had more stuff going on here, I would, in fact, go top to bottom, and this all gets pushed down. Why not? I should also say I see absolutely no reason not to use pre-job and post-job components. Even if all you do is attach a little tjava that says I've started the job and one that says I've finished the job and log it. Wow, how interesting is that in a log report that says, yeah, at least I know I got there. Okay, so use these components as a guideline, as a common best practice, right? I use them all the time. I don't ever not use them, except for in a joblet, right?
The couple of nice things about it, what I make sure that is always there in the code is you always get to choose that for whatever exception you get in the body of the code, you always end up successfully closing your job, closing your metadata, things like that. So you know that your job failed or succeeded with whatever message is.
Very true. And I'm going to call out the tDie one more time because that's the other component that will allow you to set a checkbox to exit the JVM immediately. So let's say I am opening my database connection on the pre-job, and it fails the connection. I'm going to do an on-sub-job error. I'm going to call out TDI and exit the job. Why continue processing if I don't have a database connection? Why try and query the database? I'm just going to generate more errors, right? And then it won't even go to the post job. It will never get there. But in my case here, I don't care that the file doesn't exist. I'm just writing a log message saying it doesn't exist, and it just so happens my child job creates it for me if it doesn't exist. So there's different uses for this, and you want to use these components sparingly, but use them. Okay, you don't connect them to everything, but you want to use them to create operational logging.
T-day, whatever you just told, exit the JVM immediately. To figure out that, it took a while.
It took a while.
Exact requirement. We don't want to continue our job when pre-job fails.
Yeah.
We're not able to do that. Struggling. Finally, on Friday we clicked that one setting.
And that's why we're here tonight. I don't want you to have to go through that again. Okay, so hopefully you'll get a few more of those nuggets out of tonight, okay? So the other little thing you can do is you can use the run if trigger, okay? And we're going to talk about the run if trigger as well. Okay. If I could make this number 1, I would. It's probably the most important thing you can do in Talend, is to handle your exceptions. Please, don't just write code and expect them to run and always work. Okay, things fail, and you need to handle exceptions. So now we get to look at that joblet, the log processor joblet. Okay, it's very simple, and this is just an example of what you can do. It's a log catcher component listening for exceptions. And I'm specifying down here on that component which exceptions to listen for. And look at that. Any Java exception and any TDI and any TWarn component I put in my code. Anytime one of those components get invoked, they throw an exception. And the log catcher will catch it. And then I pass it through a tmap, and the tmap fans out by priority the level of the exception, because it's not just error handling, it's exception handling. Debug, info, warning, error, fatal. And you might do different things depending on what the priority level is. In my case, it's really simple. I'm just writing out to a CSV file, or I'm sending an email. Whatever you want. Yeah?
I think people can copy your whole thing and do something in their canvas.
They could. But one of my customers did that. And he used parallelization, and he nested it in multiple jobs, and he got errors writing to the file because 5 different parallel threads were trying to write to the same file. So be careful. You need to have unique file names. So this is sample code. It's not production code. Yes, you can start here, and I'll give you this code, right? So you can do what you want. But it's not just this code that makes it work.
Are you saying as a best practice, I'm sorry to interrupt you,
Please.
that you would have this joblet in all of your jobs?
Every single one.
Yeah.
Yes.
Because when you write Java code, you actually want to do the same thing.
What a novel idea. Reusable code. Now, I've seen some customers who actually put the log catcher and an output in every job. Now, if he ever has to change that, he has to go into every single job and touch it.
Yeah.
So use this.
Error handling template for every other coding, object-oriented writing. Kind of copy the whole thing.
It's a common use.
If you want to delete any
Yep.
component, you delete by the time you check
Yeah.
the name of the project.
That's right. Now, but there's a second part to this. Very important second part to this. And you need to incorporate well-defined return codes. Okay? Return codes are things that you devise. Okay, so there's an article out here. It's a best practice on conventions for return codes. And you can see the TDI and TWarn component has 3 basic settings. A message, and it's called an error code, but we're talking return codes, and a priority level. Now, if you want to use TDI and TWarn and leave it to the default, your log is going to say the end is near error code 4 every time. That's not very useful. So come up with a guideline on how you want to construct messages, and come up with a guideline on how you want to implement a meaningful return code. So let me show you an example. And by the way, here's that checkbox that this gentleman took a while to find. It's on the advanced settings of the TDI. Basically, the TDI and the T-warn are identical Java code except for the icon and that checkbox. Okay? So let's take a look. And again, this is just an example, but we want to handle those different priorities. So I've listed them here, and this is industry standard priority levels. And here's a sample return code made up of 3 parts. The first digit is the priority. It maps to that level of priority. The second digit is the system. Where did the exception occur? And the third digit is the type of exception that occurred. So let's examine that. Priority levels. Okay, I don't care about debug or trace. You could implement those two. That's 1 and 2. So I've mapped info to 3 and fatal to 6. So there's my priority code. My system code, operating system, memory, settings, network, internet, big data file system. Where did the error or exception occur? You have a list. You assign it a number. This tells you where the error occurred. And then you have the different types. Permissions, connections, open, close, read, write, open, put, get, dump, load, whatever your operations are. You come up with this list, and just one second, and then in the end, you have a meaningful return code, like this one, a 3605. 3 means it's informational, 6 means it's at the file system level, and 05 was open. That means programmatically, I can test in my job that I opened my file successfully. And I've got a nice simple message. I'll even concatenate the name of the file in my message. Now you had a question.
So do you using the list of return code and you have a kind of an Excel chart you already print on your wall with the message you're using?
You want to document these return codes, whatever scheme you come up with, right? You document them in your developer guidelines document. You'll see in the outline it's there. Some people go so far as to put them in a database so they can be managed and maintained and looked up.
Kibana or things like that.
We're going to talk about Log4j. This is not. There's really 2 kinds of logging. There's technical logging and operational logging. This is operational logging. This is programmatic, so that you in your code can test for a return code.
Actually, we went far ahead and we took this operational from that to have all those logs, right?
Mm-hmm.
We plugged Kibana, our own Greylog server, and plugged it in so you can read all that.
You can do that.
Yeah, so that is what we did.
Yeah, there's the Log4j and the AMC, the Activity Monitoring Console, which if you set that up, all of these TDI, T-warn, and Java exceptions get pushed to that. Okay? So you can externalize these logs and query them with tools like Nagios to check for, let's say this one, a 5701. That's a 5, so that's error. That's 7, that's a database. 01, that's permissions. So I had invalid credentials. Now if I'm pinging my database and I see 10 of these in the last 20 seconds, somebody hacking my system? I don't know. But this is the kind of purpose and meaning that you have. So you need both the return codes and the log processor to have effective error handling and logging in your code. Okay? So don't avoid this. The sooner you implement something like this as a best practice and create a generic reusable module, the better off you are long term, because you won't have to retrofit and re-engineer and stick it in later, because you'll want this. Now I call out Log4j here as well. That's the technical side. Every component is Log4j enabled. So all the technical statistics and operation of a component are logged to the Logstash server, which is optionally installed. Okay? And you can have Kibana to review all that information. Okay? Here's something that confuses a lot of Talend developers, myself included, at first. And I really had to jump on this one because it gets a little tricky, right? You've got your components and the data flow is pretty easy. You're passing rows of data, result sets. But the process code is based on triggers. And you can either trigger by on component OK or on subjob OK. What's the difference? And they are significant. Okay, so here's a better job. Okay, this is now kind of a real job. And this is my label guideline. okay, with the object name, which is the underscore unique label. You know, if you go to the component view tab, this is where you set the label. And it's like HTML syntax. And you know, put your BR in brackets to do a line break. And I've included the underscore unique to get the unique name of the object, because every component has assigned a unique name which you cannot touch or change. But I can put a label in there. That makes this code very readable. Okay? But now what I'm doing here, let's scoot this up a little bit. Here is a subjob. I've even gone so far as to label the subjob. You can put a heading on a subjob. I don't do that on every subjob, but I did it here because that's the main purpose of my job. I'm processing data. I'm reading data from a database table in MySQL. This table has 100 rows. I'm filtering on those 100 rows. I'm finding 10 rows that match my filter criteria, and I pass it to the MySQL output where I write those 10 rows. Now, one of those rows happens to fail a constraint because it is required to have a value in the last modified date. And there's a null value. So that's the use case here. I'm reading 100 rows, I'm filtering out 10 and writing 9. Okay? Now, the on subjob OK message box 1 will fire after the subjob completes successfully. That means everything in the subjob executes clean. If any of those components fail to execute clean, then the on subjob error will trigger. And there's my bending the rules again, going from right to left. That's my exception handler, okay, on the subjob. All right, now I'm going to ask you, the filter row component has an onComponent OK trigger. OnComponent OK says, fire this trigger when the component successfully executes. So I've set it up. I'm reading 100 rows. I'm filtering 10. I'm writing 9. How many times will message box 2 trigger or fire?
Once.
One time? 10 times. 10 times? How many times? I said there's 100 rows, filtering 10, writing 9. So it's either 0, 1, 10, or 100, the 4 possible answers. So which one do you think it is? I've got 2 10s and 1 1. 100? 100? What are the odds? You know, we should have a little...
You said 10, 100 rows or 10 rows?
I'm reading 100 rows, I'm filtering out 10, and I'm writing 9 because I have a reject. But we're asking, how many times will message box 2 fire?
100 times.
100 times. Now we're all over the place. One time.
One time.
One time. And that is because the filter row requires processing all 100 records in order to filter and spit out 10 for it to be completely successful.
It will only work multiple times when you have an iterator.
You're absolutely right, and you're getting a slightly bit ahead of me, okay? Okay, so now I'm firing this guy once because I've filtered all 100 rows and I've passed 10 down. This guy is going to write 9. So how many times does message box 4 trigger? 1 time or 9? 1. You said 9? 9 is correct. Because this component is successful every time it writes a row. Unless, there's a caveat here, unless you have auto commit or a bulk transfer feature turned on. Okay, but essentially it's the component and the operation of that component that determines that trigger. The component has to complete successfully to trigger the onComponent OK. Now in my case, I'm handling the exception, but I'm also getting a warn thrown for that one row that failed.
I'm missing something, because you could write it in SQL. And
There's SQL in here.
I know, but it's, I mean, you could do it.
This is a simple example,
Yeah,
okay?
I mean, very simple. You know, select whatever it is,
Yeah, of course,
where.
of course.
Imagine getting a filter from a filter
Let me-
has values from a different database.
Yeah.
Say SQL versus Teradata, Oracle.
We're focused on the wrong question here then. This is a sample strictly to show the difference between an on-component OK and an on-subjob OK. All right? It's a real simple use case. Yeah, you can do this in BASIC. You can do this in SQL. That's not the point. Okay? The point is how to understand these triggers work. Okay. There's something else I want to mention about this.
I like this because I'm always modifying the name, and then that way you try to search for using both variables, and it gets all confusing. But keeping the actual unique name and then just labeling it.
Yeah, do both. I always include both. Yeah, and I bold it. I do the extra little thing of bolding the unique name, so that's why it's bold. Okay, so let me explain an example. Maybe that helps put it into context. I had a customer who was having a trouble executing a job. He said it would run for 6 hours and it would not execute, and if he did it in SQL, it would execute just fine. So I said, fine, show me the job. And we opened it up, and okay, first daying against him was it was a monolithic job. It was doing all kinds of things. It had sub-jobs all over the place. The second thing I noticed is everything was connected with on-component OK. Which meant that every time he hit here, he was triggering a whole nother sub-job, which had another one of those, which was triggering a whole nother sub-job. He was firing off sub-jobs after sub-jobs after sub-jobs, and per row. He didn't realize that was happening because he was expecting that because that component was at the end of his flow, that it would just fall through after it was all done. No. This is what happens after it's all done. That's where he needed to connect it. So we re-architected his code properly with on-subjob OKs, and the thing ran in 6 minutes. He was processing tens of millions of records. Okay? His job was still a little overly complex, and I recommended that he orchestrate it better. But just that one simple thing made all the difference. And the reason he fell into this trap, there are times when you cannot connect on subjob OK from one component to the next. And the reason it's not allowing you to do that is because it would generate incorrect Java. So it's preventing you from making that mistake. Then he made the compounded mistake of, well, but I can connect it with on-component OK, so it must be fine. No, it's not fine. Because on-component OK will trigger every time that component executes successfully. So in some cases like this, it might have worked OK. But in cases like this, he was triggering his subjobs for every single row. He must have been thrashing the hell out of that CPU. He did explain that, yeah, it was 100% pegged. Now we know why.
Dave, how do I know? In your example, your T-filter row happens one time, but your MySQL import happens 10 times, correct?
Yes.
How do I know that this T-filter, where do I go to find out?
Gosh, that's a great question. I've been asked that before. We don't have a compounded list that says, well, here's the ones that have to process all your data, and here's the ones that, like you said, iterate through your data. So there is a logical connection that you need to make and derive from the components. And think about it. Filter row, in order to filter anything, you got to read it all. To write a row, you just write a row. And there is this concept of iteration. Okay, when you're iterating through row by row, that component will complete. If you filtered an iterated row, you're filtering one row. And therefore, it would trigger every time. If I connected this to here through an iterate trigger, then the filter would trigger message box every time, 100 times. 100 times. So there you go. This is a great example.
You just got to
You're
logically
searching
think
for the
about
text
it.
string in the comment.
Right.
Because yeah.
I like that thinking. Put some comment in there. We have a note component where you can put some information.
So the one you have over there, T Warren, you got to make it bigger.
Sorry, this guy?
So executive error. So you're searching for something, and there's a null in here, which essentially tells you that the application, the input, is really not validating that something is in there.
In this particular case, my example is failing a constraint.
It's failing what?
A constraint in the database. So the database has a constraint that requires a value to have a value, and it's got a null. In this case, it's last modified date. And last modified date is null, so it's rejecting the record because the database says I need a value here.
So the application, is it, or you don't?
The database is firing the error. This component wraps around the SQL command to do the insert, and the insert is failing.
So you're writing
And this component recognizes that failure, and I write it out to T-Warn because I don't want to kill off the job. I just want to log the event. And I'm also handling a reject, which means I can capture that data and write it out as well. So I have the whole row written out somewhere else, so I can inspect after the fact, why did this row fail?
So if you're a salesperson, you would say this is a good way of testing the reliability of the database to see if it's functioning the way it's supposed to be.
You can implement something like that, yeah. Yes. Okay, now notice also I'm doing my own best practice, making my connections to my database in the pre-job and closing them in the post-job. I've seen a lot of cases where people open connections and don't bother to close the database connection. This is another good citizen thing, okay? Always close the connection you open, because then it gets closed right then and there. But you say, the database will close it. Sure, once the DBA calls you on the phone and says, why do you have 200 connections open? Well, eventually they close, maybe.
Or they'll kill it for you.
Or they'll kill it for you, but maybe they killed the wrong one. No, take the moment that it takes to add the closed components in your post job. What does it take? 2 seconds? 3? And then label it 4?
Relational databases, you want commits to be done when you close the connection. So that is very important.
There is some variances there, whether you're an auto commit or auto close, and some components let you connect directly within the component. But there's a lot of other options. This is the basics, right? Okay.
So just take, so let's say I can only execute 1,000 of something, you know, where whatever it is, in, you know, OpenPrem with 1,000 things. So if I have like 14,000 of them, it gets to be real troublesome to keep on refreshing it. So would it take some sort of Excel file and then put it in a temporary file? And then
There's a variety of things you can do if you want to chunk your data up and slice and dice it. Hey, guys, we got like 3 conversations going on back there,
no one's listening to you.
right?
I'm listening to you.
I appreciate that. Kurt, can we have one conversation? I got 3 conversations going on. It's really hard for me to pay attention. I appreciate it. Thanks. That's okay. If this isn't interesting, we can move on to something else. I got all kinds of good stuff.
I think you're just sparking conversation.
I know I am. I appreciate that. So, but bring it. Let's get everybody in the conversation.
So I gotta tell you what it was.
Please.
So Anil was saying, look, at the end of your formal training, can you add on the best practices training? Because we kind of get this structured part of the training, which is very regimented, but then we get to the end and we really don't kind of understand the best.
I've been recommending that for 2 years now.
So
I think this is perfect. So that's a perfect thing to bring up, right? So bring it up. Don't have different conversations. Everybody should hear this.
Well, let me get myself in trouble now too.
Okay?
You give me the paintbrush and the paints and all this information. Now let me use my artistic talents to do that.
Please do. You should.
You guys, we're all Picassos here.
That's right. That's right. Oh, you're going to love my slide coming up. All right. So, but here's the thing. The best time for this content, frankly, is right after you finish training. Do the training is going to teach you the tool. This is going to teach you how to use it. Okay? So I think that's a great suggestion. And feed that up, because I've made that suggestion multiple times.
How do you provide that feedback?
We're doing talent user groups, and we're doing boot camps, and we're getting that feedback, and we're telling that person, and that person to go make it happen. Hi, Laura. See that person back there waving? She's hearing this feedback. That's why I want to have everybody involved in the conversation so they can hear this too. All right. I think it's a very, I think it's a great idea. All right, let's move along. This isn't in the training. It's not in the documentation. It's something I discovered on my own. And it kind of ties everything together. In my mind, once we're building these atomic jobs and we're following the best practices 1 through 6 that we've reviewed so far, Now what we really need to do to write an effective job is identify the loop. We're processing a result set or a list. There's some kind of a loop going on. We're doing data integration, so there is a loop of some sort. That is your primary purpose of the job. So look for your primary or your main loop and build your job around it. In my case here, this use case is, well, first of all, I want to call out, I'm using a Java component here to add a little bit of extra Java code into my flow so that I can set up my configurations for my database connections. And if everything's fine, my job is started. And yes, I'm closing those database connections with a little wrap-up piece of Java code at the end. But now what I'm doing is I'm reading an Excel file. You know, rows and columns, cells. I need to process a cell and do something about it. This spreadsheet has kind of a uniform, but no, maybe kind of an abstract format. I don't know. In my case, it was fairly abstract. So I'm reading a worksheet, row by row by row by row. So that's my main loop. When it's all done, processing whatever's going on downstream, I have an on subjob okay, my file read was successful, or it wasn't okay. My file read failed, right? That's the simple stuff. Now, I'm logging the row just for grins, and I'm using a T Java flex. There's 3 Java components. The Java flex allows me to put a wrapper around my data flow so I can have a begin, a main, and an end. For the flow, that means I'm getting a chance to iterate for each row in the Excel file and inspect each column so I can identify and call out a cell. Once I have that cell, I can test to see if that cell value name is equal to names. And if it is, I can trigger a secondary loop, which is going to parse that row differently because it had that special value. Okay? So this is the kind of thing you can do. You can orchestrate loops of subjobs within your job. But that's the key, is to identify where those loops are. That job loop is, once I figured this out, all my jobs got so much easier to write. Okay, because they made so much more sense. And in the end, I'm just writing out my data, I'm handling rejects, I'm conditionalizing my errors. This is a good job design.
Sorry to interrupt. Your T-die on your SQL connections, maybe it's an implementation thing, but...
This one?
No.
No.
The
This one?
The pre-jobs.
These guys?
Right.
Yes.
Our implementation, if those fail, our job fails. So we don't have to put a T-die on that component. Is that an implementation of ours?
This, how does your job fail? If you don't get a database connection and you don't catch that exception, your job will keep running.
If you put it in a pre-job, yes, whatever he's saying makes sense. But if you put it in the main flow,
If you don't have pre and post, it will fail, because that is the main starting of your job. Because SQL can say, he did not have anything around it and says MS SQL input was his only component starting the job. So in that case, SQL current does not work.
Say my credentials are bad.
Yeah.
If your credentials are, no it doesn't.
It does in my implementation.
But you're talking about the check mark inside the component, right?
The T-die has a checkbox, on or off. Will I exit the JVM immediately or not?
No,
In this case,
my SQL connection.
it'll throw a Java exception, sure.
In my implementation, we use RunDeck. It kills the job.
Oh, well, that's RunDeck.
So that's an implementation.
Yes.
Oh, okay, got it.
Yes.
Or if the database is down, you don't want to keep on banging it.
So it's
That's true.
implementation where
So
our
your Talend job is failing and being managed by an outer scheduler, right?
Had it was saying on TAC maybe.
Yeah,
Okay, got it.
yeah. So you want to be able to control this stuff. And even with RunDeck, you should do the T-die and you should check that box on to
would give you
tighten up.
logging, wouldn't it?
It would give you the logging and you'll know why and where it failed, right? So yeah,
Sorry.
that's a good call out. They're using a different type of scheduler to run their jobs, a product called RunDeck, Optum. So,
And it captures the return code and won't be able
so are you on the Optum side that's part of OIS?
Yeah, I'm OIS.
Oh, okay. I want to talk to you. I spent some time last week at PEDS in Minneapolis. There's still 2 feet of snow in Minneapolis in April.
I just moved here from Arizona. I don't know why there's no
All right.
buds on the trees. It's May.
So enough on return codes, right? And I don't mean, I'm sorry, enough on job loops. Does this make sense? Let's just wrap up with that set of 7, I think are really fundamental best practices. And I wrap up at 8 here just to call out SDLC as a best practice.
Did you get paid for that advertisement?
No, I wish he would. I sat next to Matt Baden one time on a flight home. He's the CIO of Camping World. He told me a story. He met Marcus Lemonis when he was like 16 years old, and he had some ideas about how to build their IT, and he hired him on the spot, and he's been with them for 18 years now. Oh my God. Some guys get the break. Anyway, I love the show, The Prophet, right? But he calls out what I think is very important from software lifecycle development, which is 3 things: people, product, process. Of course, I replace product with technology, okay? So you've watched the show. You know, he finds a company that's failing and he figures out what's going wrong. He puts money in and he takes over and he fixes it, in theory. Well, let's avoid having to write bad code in the first place and have the full life cycle in place. Incrementally build it out. We've already talked about that. I think the developer guideline is the seed, the starting point, and a COE, a center of excellence, is the end point. You'll get there. Don't try and do a COE overnight. Start out with the developer guidelines and these best practices and job designs, and you will eventually get there. And that's okay. All right. Now we're going to go off into some other types of best practices. Workspaces. When you install Talend, the studio, on your laptop, you have an opportunity to specify where your workspace is. Your workspace is your local copy of the source code. In the past, the default was to put that in the root directory of where you install Talend executables, the worst place possible to put it, right? In fact, how many of you guys use SQL Server? Okay, and do your DBAs change the password, the default password for SA? Yes, they do. Because SA means anybody can log in. So they better change that password. Don't take the defaults. This is one of those cases. The workspace default is the wrong place to put your code. Come up with a guideline as to where you want to put your workspaces. And I make that plural for a couple of reasons. You might have a workspace for your dev environment, for your test environment, for your prod environment. At least that's the way we used to have to do it because we had to import and export code between those environments. Now, because of CI/CD, we only have to maintain source code within one environment. However, with Git, you might have a sandbox which is disconnected from Git, and you'll have a dev connection that is connected. So you'll have at least 2 workspaces, sandbox and dev. But what if you want to have version 6.3 and 6.4 on your laptop? Each should have its own workspace. Every instance of a connection to the TAC should have its own workspace. You shouldn't overlap those workspaces. Okay, I like putting the version number in my directory tree. So I'll have talend/64.1/dev. That's my workspace. Agree whatever you want to do as a team and make it a guideline.
You're taking a big risk putting it on your laptop and hard disk failure.
Well, it's all a copy. It's a local working copy of the code, which is all backed up on your source code control system.
Solid gonna get.
Okay? Number 10, reference projects. Who knows what a reference project is?
Kind of remember.
Okay.
Share code.
What is it?
You can share code between different projects.
Share code across projects.
Variables, context, metadata, everything around.
Everything. So we have this feature, and you know what? It works. It does work. With Git, there's depends on what version you're on.
6.1.
Yes. Yes. That's fixed. Long time ago. 6.3. That was all fixed.
Everything now Git 6.4, but the problem is you change something in the reference project. If you are referencing this,
I've heard about that one.
it will not reflect
Yeah.
it.
Yeah, I've heard about that. That's a bug. Okay. So 6.5 does. Okay, so here's the thing. For the first few years, when I learned Talend, and I didn't get to go to the training, I had to teach myself, I was so frustrated that I had to copy and paste jobs and objects between things, across projects. I hated that. Boy, Talend really messed up here. Lo and behold, there's this thing called reference project that's been around forever. And all you have to do is when you create a project in the TAC, and look what I labeled mine, common code. Project that contains all reusable code. Yeah, that's a nice description. And I took the time to put in a description, by the way. And all you have to do is check that box right there. So many things are just a checkbox, and it's huge implications. Now we've created a project that can be authorized for developers to access and write reusable code, metadata, database connections, joblets, jobs that are common that can be reused across projects. You don't have to copy and paste nothing. Because now what you do is you create another project, which is your real project. I've got one called CSA Tools here, and you go to the Project References tab, and you'll see the reference project listed, and you just click that little hyperlink. That's all you have to do. Now, when you open up the CSA Tools project, all of the objects from CSA Tools and all of the objects from the Common Code projects are included. I can use them all. The Common Code objects are read-only. Now notice it has a branch trunk, so there's branching and tagging going on, and we're going to talk about that too. So yes, you have to manage releases. But here's the thing. People will say, how many reference projects can I have? Well, the recommendation is you really only need one. However, I've come across cases in enterprise organizations like UHG where you might want to have multiple reference projects by team. And I still challenge that. Because really, does that mean everybody's going to write their own error handler? Or is that going to be common across?
Now you need two.
Now you need two. You can make a hierarchy. There's also another case where maybe a team has special code that's proprietary or secure and can't be exposed to other teams. So yes, create an umbrella project that really has the truly common code and have unique projects by team where you have special needs. Okay?
So you'd have Common Code, CSA Tools.
Potentially.
Common Code and then Common Code, CSA Tools. And then CSA Tools would refer to both of them.
Yes. You can nest them. Now, I recommend avoiding nesting at all possible. Certainly don't go past 2 levels of nesting, especially because we have to deal with branching and tagging and reversion release, and that gets really messy. Okay, so compound the problem by adding lots of reference projects. I had one customer, he's had 20 reference projects and 1 regular project. I said, what the heck are you doing? What is going on here? And he said, well, he had a good excuse. You know where you can go into a project and go down to the bottom left of the repository and generate your documentation? You can create a whole wiki on everything. He said, this way I can open up one project and generate my documentation for everything. I said, wow, that's unique. That's a great excuse. That's not what reference projects are intended for, but have at it. It's his guideline, it's his best practice. Who am I to argue?
There's one thing here.
Yeah.
When you have to add something to the reference project, I need to switch the project and Studio takes another 4 or 5 minutes to load the other project.
Maybe.
Is there any way you can allow certain developers or with certain privilege to modify the reference project from the common project?
Absolutely. In the TAC, you can see here, project authorizations. You have to authorize a user to be writable. So what you should do, actually that's a great call out, you should assign certain developers the responsibility to own the reference project. And so another developer has something I want to promote to the reference project, fine, have a process in place.
My question is not that one. I agree with that. We
Okay.
have a similar kind of setup. But let's say I'm working on a project which is getting referenced by project reference. And I have to add a new database connections in the project reference. So when I'm working on this project, I cannot add it there because everything is read-only from there. So I need to switch my project from the studio to go that project.
Yeah.
And is there any way you can allow or any suggestion to allow from the actual project to add it in the reference?
No, there's no promote from here to there. They're separate projects. Write a support ticket as a feature request, please. Here's the reason why. Here's the reason why. If I wrote it, I'll tell you why. If you need your body, if I wrote that ticket, they're not going to pay attention to me. I'm not a customer. You write the ticket and you talk to your CSM. Okay, not your AE. He can't help much. Talk to your CSM. Who's his CSM? Is it Aaron?
Srini.
Srini? Talk to Srini.
Did you hear what he said though? He said, I'm more powerful than
You are. You are, and you're more powerful than me. They will listen to you. They won't listen to me. We will always propagate to JIRA tickets faster when they come from a customer. And we listen to our customers, and a lot of features in 6.5 were, I think 80% of them were customer driven. So we do that all the time. So don't hesitate. Okay, it means writing a support ticket. Is that really so hard? It means there's a chance you're going to get the feature added. If you just say it here tonight, it's not going to happen.
I open a ticket, they'll ask me a log, so I don't have a log for that. That's why.
All right, well, sounds like a personal problem. Okay, here's another one I'd like to be number one. Naming conventions. Rose by any other name is still a rose. Of course, we're talking about Shakespeare, but who cares? The point is, have a naming convention. Do it as soon as you possibly can. Before you write a single line of code, please, if you can. Often you can't. Often it's too late. You're already well downstream and you're writing all of this. 10 programmers are writing code and naming things completely differently. That's okay. Stop now. Go to your developer guidelines document, come up with a convention for object naming and create a convention for everything. Job names, object names, database connection names, project names, directory names, file names. Everything under the sun should have an object naming convention. I don't care what it is. Just pick one and stick with it. It can evolve, right? Make it agile, but do it. Now you have a choice. Do I go back and retrofit my existing code and apply the object naming convention? That's a tough call. How much is there? Is it worth the investment? Usually the answer is no. So you pick that date, and from that date forward, you deal with the legacy bad naming conventions. And
do you have a sample of this development code that you keep referring to?
The guidelines document is right there.
For my object names?
Oh, yeah, this link here, conventions for object naming, you want to see that? Yeah, there's.
Okay, that's.
Yeah. So go to help.talend.com and look for this article. Oh, broken. Broken. All right, well, let's see if we can find it the real way. Help.talend. I know. Let's do it the old-fashioned way. Let's search for it.
You mean Google for it?
No.
We don't use the word searches like that.
There it is. Okay?
That's awesome, thank you.
Now, my boss and I wrote this one. Okay? So it lists everything. And these are just suggestions, but it gives you a starting point. I mean, this is a long article. Now that you've made me open this, I'm going to call out one particular. See, I even have workspaces in there, right?
Kick us out? No. Oh, okay.
Okay, so I like having a naming convention for data files. These are files that I write out. And my preference is to have a date on the front of the file name. Year, month, day. You can sort it by date outside of the system. This is a great convention, right? Year, month, date, plus the file name, dot some extension. Okay, so all of that is in this article. Okay? And it's a long article. It goes through lots of things.
You said every object.
Everything.
Every object you thought.
It's what we, yeah. And you can see objects to consider. There's a whole list of them here. So there you go. It's a starting point. And do it right away. If you haven't already done it, that's number one on your list next to return codes, right? Okay, number 12. We're getting through it. We're almost done. Now the project repository. You all understand that we're creating metadata, not just jobs. The job is the Java code that's being generated, but we also have a lot of metadata, which are all these shared reusable objects that get created in the project repository, which is that panel on the left side of your studio. Now above metadata is where you have, oh shoot, I clicked the wrong area, there we go. Above metadata you have job designs and you have your code routines and you have your context groups and stuff, but open up metadata. And if you don't have anything defined in metadata, you're not using the product to its full advantage, okay? You can create your database connections here. You can then contextualize your database connections. Guess what? Put those in your reference project. You can create mappings to all the different types of files that you might be processing in or out. You can create types of files like Excel and LDIF and JSON and LDAP and Salesforce connections and Snowflake connections. The one I want to call out here is generic schemas. Generic schemas is a very valuable tool. This is where you can define your own structure, your own schema. Let's say you have in your database a table with 16 columns, and as a result of a join, the output result is 20 columns. Well, you need a generic schema that has all 20 columns in it in the project repository so that it becomes a reusable object. Now, when you reference the reusable object in your job and it changes, you change it in the project repository, and everywhere it's used, it will inherit the change. You don't have to go into every place and modify it over and over and over again. Now, you may notice when you're inside a job, you can create an object right there and then, and it's called built-in. Okay, that means it's localized to that job. It can be reused within that job, and when you change it from a built-in integer to a built-in string, that job changes. But what if it was out in the project repository? That means it's shareable across jobs. And of course, if that object is in the reference project, it's shareable across projects. So use the generic schema, use the metadata section, promote your built-in objects to repository. You can do that. We can't promote from a project to a project, but we can promote a built-in to a repository object. There's a little disk button to save, and it will ask you, do you want to save it in the repository? And say yes. Do that. That way you only have to change it in one place, and everywhere else it inherits the change. Additionally, I have another neat little trick that I came up with. In the context variables section, I create a context group I call system vars. And these are all my really high level, often used variables that everybody's going to have, like string date, you know, and I have one here called sysenv type. And then I assign it the value of my environment context. Now, what does that give me? That gives me programmable control of what happens next in my code based on the environment that I'm running in. So if I tell the job to run in dev, I can test. If sysenv type is dev, do this extra logging by the run if, put an expression, testing that variable. So I can determine at runtime what environment I'm running in and make my job smarter just by doing something like that. Any kind of flag you might need, but this is a good one just for the environment type. You can probably get some ideas on how you might use that same trick in a variety of ways. Okay, version control. This is an important one. People get this one messed up too. We have a legacy thing in Talend. If you right-click on a job, you go to Properties, and you see these two buttons, Major and Minor. And wow, you click them, it increments the version. No, you can't go backwards, but hang on, it's worse than that. This is designed for single-user Open Studio customers. Well, they're not really customers because they're not paying for it. They have to have version control too. And of course, when you click that button and you go back to the project repository, you see nicely that little number to the right of the job name increments. 1.1, 1.2, 1.3, 2.1, and so on. Don't use those buttons. They're not for you. They're for the single user customer. The reason is because you have a source code control system behind you. And that's the system you should be using for branching and tagging and managing your releases. Because why? Every time you click those buttons, it creates a copy, a full copy of that job in your workspace. Every time you click that button, it creates a copy. Now this copy, this workspace is connected to the source code control system, so every time you open and close the studio, it has to synchronize all your files. I had a customer complain, Talend sucks, it's taking 15 minutes to open my project. Send me the project. Sure enough, it took me 15 minutes to open his project. That sucks. I looked at it and said, well, there's 450 files, jobs in here. That's a lot, but it shouldn't take 15 minutes. And then I noticed every job was like 11.2, 18.3, copy of 16.9. And I looked under the hood, there was 9,500 copies of these 450 jobs in the workspace. So, okay, it takes 15 minutes to load 9,500 jobs. So we exported the project, including just the latest copy, re-imported it, the thing loaded up in about 4 minutes.
Is it hard for you to take it out the motioning from the enterprise?
Is it hard to what?
Just not allow the people to use the motioning in the enterprise?
I've asked that question, you know, they tell me that it's too big of a change and it would mean separating the code base for our single open studio users from our subscription, and
Well, when you're
no.
scheduling in a product like Rundeck, and 99% of your jobs are .1,
Yeah.
then somebody had clicked the 1.0.
Yeah, well, you should always set it to use latest, and that solves that problem. But if you're implementing proper CI/CD, it's not a problem, because you're publishing and promoting releases and snapshots of binary objects. So you're not recompiling the code each time.
But we still have to put the version in.
You should, and you should use branching and tagging in your source code control system to do that.
But you just always type .1, except for this job, it's 1.0.
Tag it. You should be tagging your jobs. Okay, tag, and actually in SVN and Git, you tag the project. Okay, so branching and tagging is a very important thing to do. So there's a best practice here. You need to decide as your team. There's like different ways you can branch things. Do not branch by developer. Do not branch by environment. Branch by version. You know, create a release. 1.1 is a release. That's a version that you're going to put into test. It's a release candidate until it passes test, in which case it's a release, you go into production. And it has a branch, so that you can always go back to that branch and modify any code to fix bugs, which is a patch, right? But now you've got that branch. A branch is a full copy of the master or trunk, where it came from, and the tag is a snapshot on that branch or trunk. So you can always go back to that tag. That's I use tags for point releases and branches for major releases. That's just a general way of approaching it. But definitely don't branch by developer, and definitely don't branch by environment. That's wrong. Okay? Now with Git, you have the option of having a sandbox, and that way you can kind of start developing offline from the GitHub repository, and then you can merge your code back into the trunk or the branch of choice. And our tool will give you a side-by-side visual comparison of current code in trunk and current code in your workspace, and you can merge the differences. You get to choose at a component level what survives. Okay, and that's as of 6.3. Prior to 6.3, 6.2 only lets you choose the job that survives, but we've now expanded that to the component level. All right, I hinted at memory management before. This is one of those things that there's really not much you can do, except for be smart. Think about what you're doing in your job. Are you processing millions of rows of data? That's probably going to need memory. Are you processing hundreds and hundreds of columns? That's probably going to need memory. Figure out how much memory it is. You may have a lot of T maps with lookups. That's going to use memory. You may have 32 gigabytes of memory on your job server and have a job that requires 64 gigabytes. That's a problem. How many parent-child nesting levels are there? Are they running in independent JVMs with their own memory heap allocations? Right? All of these considerations matter. Probably one of the biggest impacts is parallelization. And we're going to talk about that as well. That's number 16. So we're getting there. But here you go. You asked about this before. Somebody did. In the Run tab, you can go to the advanced settings and you can set specific JVM arguments. By default, you have the min and max memory allocation. Now, the maximum is the one that matters. If you have a job that needs 8 gigabytes, you have to go in here and change this to 8096 or whatever it is.
Or AZ.
Huh?
Or AZ.
Yeah. Whatever the XMX parameter accepts. I think it does accept the G. Just G. I think it's just G, yeah. Yeah. You can also add other JVM arguments to this list if you have the requirement for it.
I have a question.
Yeah.
I set up 8 gig RAM, 8 gig max memory, and then I send the job to production.
Okay.
So that the job needs 16 gig.
In that you can do that. Go to JVM properties and you can.
I was just going to mention that.
Oh, okay.
You can.
Main job level, you cannot go deep to the sub job.
Oh, sub-job.
No. Child jobs. Okay. This is why this is important. The only setting you can affect in the TAC is the parent job setting.
Exactly.
Okay, so how you orchestrate your job is important. And if you've got that 3-level nesting, it's that 3rd level job that you need to be very careful and go in here and set. But aha, check this out. There's a new tab here called Memory Run. Have you looked at that?
I tried to run it, but never understood what it is.
Okay, it's really simple. From the studio, you go to the Run tab and you click on Memory Run and you run your job. And it will give you a graphical representation of your memory utilization by component. So you get to see. Of course. But it gives you at least a hint and some visualization into how much memory your job needs so you can set those values properly. Now don't do what somebody we know did. Fred, I think you might know who I'm talking about, but I won't mention any names. Where they were setting the minimum level to 1 gig for every job. And then they calculated out how many job servers they needed, and it was like 75 job servers at $3,000 a pop per month. That was crazy expensive. And the reality was those jobs didn't need a minimum of 1 gig each. So we gave that advice. They reset that back down to, I even set it to 128 megabytes. Really, really small number for the min. And suddenly they didn't need 75 servers, they only needed 24. How much money did that save? I think that might have been the other group, but a lot. That was millions of dollars a year in savings just by that one dang setting.
How do you recommend now? Let's say I have 3 jobs. 3 of them I want to run in parallel, and 3 of them should be called from a master job. So what my current design is, all 3 sub-jobs have a JVM parameter of max of 4 gig. So 3 of them running in parallel, 4 gig RAM is okay for my job setting.
Okay.
Now I needed a requirement to bump that to 6 gig. And I cannot do that because I scheduled a main job in the tab.
Right. Well, we're going to talk about parallelization in a minute because there's different ways to orchestrate parallelization. And let's hold off and we can address that point in a few minutes. Okay? So memory management is clear. Yeah?
From job server point of view, like say I have a state-of-the-art boxes, like newer boxes, SSD and things like that. Should I go for like a 2 terabyte RAM system or split 64 GBs or 24? Like, yeah, I know, I'm like, that is what I have, but
right.
I have to choose like, do I need 10 job servers or I can do 2 massive ones?
Well, that's a great question, and it really goes to the size and shape of your ecosystem and the use cases you're trying to process on them. Okay, job servers can be configured 2 ways. You can scale horizontally or you can scale vertically. Okay, scaling vertically means that you add more cores and more memory. Boom, beefy boxes. You do that when you have single jobs at the very least that require that much resource. Otherwise, you scale horizontally. You scale down the size of the box. I'd say 16 gigabytes is the bare minimum. 32 to 64 gigabytes is the sweet spot. If you really got a lot of jobs that you want to run on it, 128, maybe 256 if you really need it. Okay, 8 cores. That's it. Okay, but these are just guidelines. There's a document on reference architecture that I could point you to that talks about how to figure out the size and shape of your job servers. But here's what I want to get to. The scaling comes from using virtual job servers. Okay, so in the TAC, there's a way to define a virtual job server that lets you pull in a physical job server with a virtual name. Now, you have to understand that when you deploy a job, you actually create a task, which is a wrapper around the job you define in the TAC. That wrapper defines a few things: what context group it's going to run on, what your logging levels are going to be, and what job server to execute on. Okay, now you probably don't have that because of Rundeck. Okay, so you do that and you deploy it to a virtual job server, and then your task will run on an available physical job server in the virtual bank. 2, 3, 4, however many you add to it. But here's the neat part. You can add or take away job servers from that virtual, and it won't impact your jobs. Now, I should point out that job servers do not do load balancing. It does what we call distributed utilization. Okay, you may have noticed in the attack there's 5 stars underneath the job server name, right? And that's an algorithm that's calculating in the background as to how much that job server is being utilized, core and RAM, right? And as soon as it gets up to like 4.5 to 5 stars, it's pretty much fully utilized. And if you ask the task to run on that job server, it will wait until that job server is available to handle that task. However, if you have a virtual job server and send it to the virtual job server and one of them's busy, it will automatically default to the next one and distribute the utilization. Now, it won't balance that utilization. You might have 10 jobs and they'll all run on the first physical job server. That's because it can handle it. But job 11, boom, goes to the second physical job server. And boom, second physical job server gets utilized, you can add a third, and so on. So you can scale out or you can scale up. And the way you size and shape those job servers is really dependent on your use case and the volume and number of jobs and their memory allocations and core utilizations, job design patterns, best practices all factor in. Okay, so it's not an easy trick to size and shape those things, but it's not that hard either.
We got everything as 8 and 64, but now we are totally into a lot of new jobs coming in, so I was just trying to think, should I change the paradigm, like go for the main box itself or still go to VMs?
And it really depends. I'd need to know more about what you're doing, but a 2 TB job server doesn't make a lot of sense. And of course, another thing I should point out, by the way, most of these things, while a lot of them are common, we're not talking big data yet.
Oh, okay. So what
Okay, big data is a whole nother ball game on some of these things, right? So if you have a Hadoop cluster, your job server can be really small if you're running MapReduce and Spark jobs, because then you're handing them off to the Hadoop cluster to execute. And the job server doesn't need to do much work. But that can be confusing because maybe the job is actually doing work because it's writing data, reading from an Oracle database and writing it to HDFS. That isn't MapReduce. That requires a job server on an edge node. You get my point, right? So there's lots of things going on. Now, before we wrap up, I got one more best practice after this one. As developers, we run into this problem all the time. We may not know the table name exactly or the where clause in a SQL query until runtime. And the database components have a query section where typically you hard code your SQL query directly in there, enclosed in double quotes. But it's fairly easy to set up some context variables, and you see my naming convention is pretty obvious what those variables do. I can use a tjava component to construct at runtime based on flags and settings and data that I've read out of the process up to that point and construct my SQL query. Now that SQL query still has to have a fixed schema. So don't ask me about schema lists yet, please. That's new stuff. Okay, this is just standard basic SQL queries. If you've got 10 columns, you need a schema with 10 columns. You can dynamically rename those columns as long as the data types match and really go whole hog with this dynamic SQL syntax thing. Okay, but this is how you do it, and it's really straightforward. You just concatenate it all together in that same SQL query box.
And why would you do this?
Because you may not know what the where clause is until runtime.
Oh, based on the data of the job before, the component before.
Now, one of the things I do, because I have that sysenv type and variable, right, I can test if dev, add a SQL limit. If I'm connecting to a database with 10 million rows and I want to iterate through my debug cycle, I don't want to read 10 million rows. I don't want to kill it off. I put a limit of 100 rows. But in prod, it won't put the limit on because I've got a conditional expression. I've made it a little bit smarter and I'm constructing my SQL at runtime, so maybe it'll include the limit, maybe it won't. Right? So there's lots of neat little things you can do with dynamic SQL syntax. You don't have to hard code it. You could read it in from a file and stuff it in there. And that way externalize your SQL query. There's lots of neat things you can do, right? Just ideas. Okay. I know we're getting close, right?
You're coming.
16 is all I'm covering tonight, but I have a couple more slides, so we're almost there. But this is the big bang, right? Parallelization. And I have to be really careful. I don't want to call it paralyzing code. That's not what we want. We don't want to put our code in a wheelchair. We want to parallelize the code. Get that out of your mouth a few times, you'll see what I mean. Talend provides some pretty neat methods for parallelizing your code, which means what? Makes it faster. It's an optimization technique. And if you use these techniques properly, you will most undoubtedly improve performance. You'll optimize your code. And what did we say at the beginning? Functionality first, optimization second? Great. So don't dive in trying to parallelize your code, because that's what you'll do. You'll paralyze it. What you want to do is parallelize it, which is an after the fact. Now, if you don't do it right, you can create yourself a lot of grief. So I want to put an image in your head. Think about bad parallelization as similar to a mushroom cloud. Boom. You can blow up your code, you can blow up your job server, you can get your boss really, really mad, your DBAs will be on the phone, what's going on here? You're tearing down the system. Yeah, you've got to be really careful about how to implement parallelization. So I've put together what I call the parallelization option stack. Now we're going to come back to your point. We start with the easy one, execution plans. In the TAC, when you create a task, you can create an execution plan to say, run this task. And if it completes, run another task. If it has an error, run that task. And you can orchestrate and string together jobs. The nice thing about that is that those jobs can be specifically assigned to different job servers. So you can manage the distribution of utilization of your job servers and manage it through an execution plan. And execution plan has a checkbox. Another one of those funky little checkboxes to enable parallelization, which means run these jobs in parallel. No, run these tasks in parallel. Now that means you have to have written the jobs to run independently, stand alone, even though you can orchestrate triggering one job after a next, but not while you're in parallel mode. You want them to all run at once. But wait a minute, what if your job server can't handle 20 tasks at once? No problem. There's a threshold setting. You can say, we'll run 5 at a time. So when you launch the execution plan, while you have 20 in the stack, it will launch the first 5. And as soon as one's done, it'll start the 6th, and on down until it's gone through the whole set of 20 and it's finished. Okay? So that requires 0 code. Just a little thought into your job design up front. What if you need a little bit more logic around this? Then you go to what you were suggesting, a parent job that can orchestrate child jobs through parallelization. Now, first of all, let's look at multiple job flows. And you know what? Shoot, I missed something. Do you remember back when we were talking about the entry and exit points? I should even pull this up. You know what? I'm going to. This is important. It will make more sense. Let's call this out. I can get to it easy enough. Okay, this is the slide I'm talking about. Okay, that was a long time ago, right? Now, okay, pre-job, post-job, child job, joblet. What else is unique about this? The green backgrounds. 4 of these components have green backgrounds. The rest of them don't. Those are entry points. I'm sorry, I forgot to mention that. That's important because this is critical when you think about parallelization. You can actually have multiple flows that are not connected within the body of your job and effectively spin up not multiple threads, but multiple process flows within the thread. Okay, and that can work. It's not true parallelization, but it is essentially running multiple processes simultaneously. At least it appears to be. Under the hood, it's not exactly, because it's having to share the thread and the stack on the same JVM. Okay, but yeah, those green boxes are entry points. Now there's 4 of them. How can there be 4 entry points? Well, we explained the pre-job, post-job. Those are obvious. The body, that makes sense. And we saw that the log processor is a log catcher, which is a listener. So in this case, the log processor starts first, The pre-job starts next, the body goes next, and the post-job finishes. Those are all 4 entry points to the job. Okay, sorry about that. Now let's go back to 16. This guy here. Now it makes a little bit more sense, right? Multiple job flows, that's what I'm talking about here. Multiple entry points within the same job, all sharing the same thread. But what if that process flow calls a T-run job and you check the box, run an independent subjob? That means that child job will spin up its own JVM. Now you really do have true parallelization within your job, and you can put some logic on it. You can set some flags, check some flags, do whatever other things you need to do. Read from a database first. So combine these two things and you effectively have a programmable execution plan. The trade-off is, to your point, the parent job is what's getting the task wrapper, and that gets submitted to a job server. So that job and all of its child jobs are running on one job server. You can't distribute them across job servers anymore. So that's the trade-off between the two. So wherever you can, use the execution plan. Wherever you need to, use this technique of combining the multiple job flows with the T-run job. Or use a component. We have 2 types of parallelization components. The first one is the T-parallelize component, which allows you to link multiple process flows. Right, so you drop in the T-parallelize component and you can link up these multiple flows. Each one will get its own thread, regardless of whether you're calling a subjob or a child job. They'll get their own thread, and if they're all on the same JVM, that's fine, unless you call a T-run job where you check that box to run in its own JVM, where now it has its own thread on its own JVM. Right? See how it's starting to get tricky? Remember that mushroom cloud? Don't nest T-parallelize components too deeply. You're going to be having threads, launching threads, and that can get dangerous. Okay? I'm not saying don't do it. I'm saying be very careful when you think you have to do it. If you really need it, and I've seen some cases where it makes a difference. One guy's processing one big file on one thread and lots of little files that are getting chunked into other littler files on other threads, and so it makes sense in certain circumstances. That's process flow. There's also a way of using components to parallelize the data flow. So we're processing 20 million rows in a data flow. Can't we make that faster? That's a bottleneck. Sure, you can use the P-partitioner, T-departitioner, T-collector, and recollector components. All 4 of them are required in your data flow, which will allow you to specify how many threads to spin up and what's the partition key. So you can take those 20 million rows and create 5 threads and do 4 million rows at a time simultaneously. And the rest of the flow is all your regular normal components, T-maps and T-filters and whatever else. You don't have to do anything else except for include those 4 components. Now that's a little bulky, you might say. And I'll give you an example of how bulky it can be. But we have another option, which means you can right-click on the row. You know that line, the orange line that says row? If you right-click on that line, a menu box pops up, and one of those options are parallelize. So you click on that and it'll open up a dialog box where you can specify the partition key and the number of threads. Great, that means you will allow the same functionality as these 4 components without putting in the components. But there's a trade-off, like everything else. The trade-off is fairly simple. When you use the component, you can test for errors. When you don't use the component, you can't. Okay, so I had a customer. I like using examples, it's the best way to explain. They were an e-commerce shopping cart. They were processing the shopping cart for pricing and product and inventory and all this stuff. So they had 20 lookups on a T-map. And to make it fast, because it had to be, it was on click, I'm paying now, it has to be pretty slick. There was a bug. And because he was using the row parallelization, he couldn't find it. There was no way to trigger where the error occurred. So we actually went in and put all 4 of those components on all 20 lookups. We found the error, it was a missing semicolon. That simple. but it slowed the job down by 8 to 10%. So after we fixed the bug, he took out all those components and went back to the original because it was faster. So trade-offs, guys. Functionality first, optimization second. Okay? Now the last thing you can do is on the other side, the output side. Inserts, updates. You can use most of these DB output components allow you to specify parallelization like bulk insert. And you can just set the number of threads on how many rows to insert or update at a time. Now you might have other considerations like auto commit and connection pooling and shared connections and all those things. But as a developer, the recommendation is to try to go between 2 and 5 threads. And so if you're processing 20 million inserts and you set it to 2, you'll probably get it done twice as fast. You set it to 5, it's probably not going to be 5x, but it's going to be faster than 2x, right? Because there's a cost to spinning up threads, allocation of memory, deallocation of memory, all that stuff. So you might go to 10 threads and it didn't give you any better performance than 5. You go to 20 threads and it's slower. So be careful about this. So as a developer, you want to go in there and kind of play with that number. I recommend making it a context variable and passing in a thread value and figure out at runtime in a UAT scenario what the best number of threads are. Okay? Great. Whew. It's been a long night. But I really appreciate all the interactive conversation. Let's just wrap up with a couple of slides. I think this is important. A two-legged stool will fall down, even if you're not sitting in it. Software, same thing. You have to have the use case, and you guys know what your use cases are. You have to have the right technology, and we really appreciate you using Talend as part of that mix. But you also have to have methodology. We've talked about SDLC. In the second half of this presentation, which we're not doing tonight, I'll come back, talks about the database development lifecycle. Okay? And I talk about that also in my blogs. So you have to have all 3 of these things to be successful. Now, remember our foundational precepts? I do have a number 1 favorite, and you nailed it. Consistency. That to me is the number 1 precept. Why? Because even if you do it wrong, you did it the same way. So you can fix it. Okay? Much easier to fix something if it's done the same way. Yes? Got to be the same. Yeah, you're right. So there we go. That's my thought on that. And here's why I thought you might like one of my slides. Pablo Picasso, because we're painting code, remember, said action is the foundational key to all success. What does he mean by that?
Just do it.
There you go.
Get it done. Stop talking about it and do it. You got to talk about it. Don't get me wrong. You got to sit together and figure it out, but don't make it a constant conversation. Get it done. Don't be afraid to make a mistake. Exactly. This is an agile process. You're going to make mistakes. You're going to learn from those mistakes and get better and better at doing things. So just remember, instill that discipline, develop guidelines, not standards. You want things to bend and not break. And then my final slide, yay, list of some do's and don'ts. And I'll just leave this up here and I'll take any other questions.
So, one question. You mentioned about the parallelization and everything, right? What happens if the job failed for whatever reason, right? Server went down or something? How does, because I don't know Talend, how does it recover from that?
There are ways that it recovers depending on how you deploy. We have recovery checkpoints, and we have in the TAC, if you're using the job server, which you're not, you have the ability to specify what to do.
Oh.
Wait, restart, or pick up where it left off.
Oh, so it can pick up where it left off.
If you specify recovery checkpoints, that's best practice in the second set.
Oh.
I look in my blog. I think it's in part 3 of my blog.
You work on data stage, right? Data stage.
Yeah.
So that is one question what I need to ask. Talend people to improve. There is a console called data stage director. Talend has to build one console like that. That is really.
And you know what I'm going to tell you? Write a support ticket and provide us that feedback. But actually, we do have some of that functionality in the TAC, right? It's not like data stage. I know. All right, well, that's all I got. Thank you all for bearing with me and participating. I appreciate it.